Question 17 reads, if p, r, and s are three different prime numbers greater than 2, and n is equal to p times r times s, how many positive factors, including 1 and n, does n have? Now there are a number of ways to attack this factors question, but I'll show you the one I think is the easiest. Let's start by listing the factors that are already given in the problem. We know we have to include 1, and we have to include n. And of course, if the prime factorization of n is p times r times s, then p, r, and s are certainly factors. So we've handled all of these factors. What's left? Well, additional factors of a number are any combination of its prime factors, so we can multiply its prime factors together and get additional factors. Now, we already have the factors that arise from multiplying just one of the prime numbers together. That's just p, r, and s by themselves. And we've also already written the one that you get when you multiply all three of them together. That's n, right? Because p times r times s is n. So the only combinations we're still concerned with are the two number combinations. How many different ways can we multiply just two of these numbers together? Well, we have to multiply two numbers together. We have three choices for the first number, and then only two choices for the second number, because none of these factors are squared or anything like that. The last question to ask yourself before computing this is, does order matter? Here it doesn't, because if we switch the numbers in the slots, like if we multiplied p times r and switched it to r times p, you'd still get the same number, so you don't want to overcount that. In order to make sure that we don't overcount them, just make sure that you label your slots underneath 1 and 2, and now you can just multiply these fractions to get your answer. 3 over 1 times 2 over 2, that cancels, is equal to 3. So there are three two-number combinations of these factors. Of course, because we're dealing with small numbers, you could have just written them out. Those three factors are p times r, p times s, and r times s. But no matter which way you choose to do the problem, the answer is the same. There are 1, 2, 3, 4, 5, 6, 7, 8 factors. So the correct answer is 8.